Hello, geometry students. We are going to review topic 7, which is all about similarity. And the first question is asking, how are properties of similar figures used to solve problems? So what we looked at in this chapter is sides and angles and proportions. So we can compare angle measures and corresponding sides to see if the figures are proportional. And when we set up proportions, that will tell us if the figures are similar. There's also some theorems about the angle bisector, or the triangle angle bisector theorem. There's the mid-segment theorem, the side splitter theorem. So different theorems will help us prove if the triangles are similar. Number 2. So this is the vocabulary review. 2 triangles are similar. So 2 triangles that are similar have 2 pairs of corresponding congruent angles. So we used similar. A blank is a composition of a dilation and one or more rigid motions. That one isn't going to fit, so we'll just draw an arrow. That would be a similarity transformation. So I guess we could draw arrows, but you'll actually learn better if you handwrite it, so I'm going to leave similar there. A point that is its own image in a dilation is the center of dilation. As a result of a dilation, if A prime B prime equals N dot AB, then N is the scale factor. Because that's what you're multiplying by. Now, just because we didn't use these vocabulary words, you should still know what they mean. Dilation, geometric mean, and you can look those up in your notes, or you can do a Google search. All right. I recommend that tonight you go home and you study these notes and you try to cover them up and see if you can still figure out the answer without the video. And if not, go ahead and rewatch this video. But lessons 7.1 and 7.2 have to do with dilations and similarity transformations. A dilation is a transformation that maps a point x to x prime such that x prime lies on the vector cx and cx prime equals k dot cx with center of dilation c and scale factor k. So you should know what these variables are representing. 2 figures are similar if there is a similarity transformation that maps one figure onto the other. So we start out with mapping figures. An example says, are triangle ABC and DEF similar? Explain. So in this example, they are reflecting over the y-axis, and that would give us the triangle. You can't see it, but it would give us this triangle. And then from there, the dilation D2 maps the image to DEF. So we can show that because this point here is at 1 comma 0 and it goes to 2 comma 0. And this point at 2 comma 0 goes to 4 comma 0. And this point, which is at 1 comma 2, goes to 2 comma 4. So that's why it's a dilation of 2, because it's getting twice as big from the origin. And since there is a mapping with a dilation and a reflection, then the triangles are similar. All right, so you may have some questions on your test that ask you to give the coordinates of each image. So we're on number 6 right now. They're asking give the coordinates of each image, dilate 1/2. So if we're going to dilate by half, then f prime is going to be 5 divided by 2, which is 2.5, and negative 2 divided by 2 is negative 1. Then you're going to have g prime. Negative 2 divided by 2 is negative 1. Negative 4 divided by 2 is negative 2. And then h prime, 0 will just be 0. 6 divided by 2 is 3. Right. Number 7. Not sure what this means, the k, and you're not going to have a question with a k on the test. But because k means the scale factor, but that's usually a little k. So again, I'm not sure what they want us to do, but we're just going to ignore the k and go with d3, which means we will multiply each coordinate by 3. So k will be 0, 12, sorry, k prime. L prime will be 9, 0. And m will be negative 6 and 12, because we multiplied by 3. All right, number 8. What is the similarity transformation from PQRS to WXYZ? So it definitely looks like a reflection and it's getting smaller. So we'll start with that and then we'll get more specific because we do have coordinates. So a reflection and a dilation where it gets smaller. And then we'll write it a little bit more like our examples that they give us in the book. It's more official. So because we're reflecting, it looks like we're reflecting over the x-axis. But then we have to translate it down because if we just dilate it, it's going to let me see. It's going to be at 0, and then when we multiply by 0, it's just going to stay at 0. But after the dilation, we could just translate it down. So that'll work. All right, so we're going to reflect it over the x-axis. And then we're going to shrink it by 1/3, so a dilation of 1/3. If we do that, this point stays here. This point is going to end to here, then come to here, and then this will go to here. I think so. Oops, hold on. So I'm reflecting it maybe I'll reflect it first and then I will dilate it, so that way it's a little easier to show if we reflect it first. Oh, I think I understand number 7 now. They were saying dilate it about the point K. But again, there's nothing going to be on the test like that, so I'm just going to leave it as 0, 0 that we dilated on number 7. And now you're going to move that, or we'll dilate it first by 1/3. So this point will stay here. This point will move to here. This point is at 3, 3, so it's going to come, or positive 3, negative 3, so it's going to go to positive 1, negative 1. This point is at negative 3, so it's going to go to negative 1, and it's negative 3, so negative 1, so it's here. And then we have to translate it down 1. So how would we write that more formally? The first thing is going to actually go last. So we're going to say P, Q, R, S is what we are doing a similarity transformation to. We're reflecting it over the x-axis. Then we're going to dilate it 1/3. And then we're going to translate it down 1. So we're not moving it left or right, so that's 0, negative 1. That's a little messy, but that's what you have. You have the translation 0, negative 1, dilation 1/3. I can make that a little bit better. Reflection over the x-axis of PQRS. Number 9. Isabel says that the scale factor in the similarity transformation that maps triangle ABC to PQR is 2. Is she correct? Well, I can definitely see that from 4 to 8 is 2, but it doesn't look like these triangles are similar. The angles don't look right. So if we rotated it, and we put 7 on the bottom, and then 4 here and 5 here, then 7 times 2 is 14, and 5 times 2 is 10, and 4 times 2 is 8. But it didn't really look like it was until I flipped it and rotated it. So you have to rotate and reflect and then dilate. So yes, because you can rotate, reflect, and dilate, which is a similarity transformation. We could also set up proportions to show that, because each thing that we multiplied by 2, so it's proportional. Similarity transformation, proportional. So you should know what these words mean and be able to use them in your explanations. And you will be allowed to use this review page on your test tomorrow. All right, flip your page. 7-3 was about proving triangles similar. A pair of triangles can be shown to be similar by using the following criteria. Two pairs of corresponding angles are congruent, or all corresponding sides are proportional, or two pairs of corresponding sides are proportional and the included angles are congruent. So two pairs of corresponding sides, included angles. So if you remember, oops, sorry about that. This is angle-angle similarity. This was side-side-side similarity. And this was side-angle-side similarity. An example. Explain whether ABE and DBC are similar. So we're looking at this triangle and this triangle. Are they similar? By the alternate interior angles theorem, AE is similar to DE. Or I'm sorry, angle A, I don't know what I'm saying, is similar to angle D. And that's because the lines are parallel and those are alternate interior angles. EC and CE are also congruent because of the alternate interior angles theorem. And since the two pairs of corresponding angles are congruent, which is shown, then the triangles are similar. Triangle ABE is similar to triangle DBC. And they want us to show if the triangles in these exercises are similar. All right, number 10. Is triangle FGJ similar to triangle JH or JGH? And we want to use one of the theorems that I wrote on the side, angle-angle, side-side-side, or side-angle-side. Well, they've given us sides and they've given us an angle. So we can say that angle HGJ is congruent to angle FGJ because they're both angle G and they're both 90 degrees. Then we need to set up a proportion to show that the 4 and the 6 and the 9 and the 6 are proportional. So the 6 is the height of the purple triangle. If I were to flip it, which corresponds to, this will be the small triangle, and then 9 and 6 will be the larger triangle. These are proportional because 4 times 9 is 36, and 6 times 6 is 36. So 36 is equal to 36. So we can say that they are proportional. Now we need to be a little careful how we do that. So where did I get this? The 6 from? That was GJ. And the 4 came from HG. And then the 9 came from FG. And then the 6 was GH. So since we have an angle in between the two sides, then we can say that they are similar. So similar by side, angle, side, similarity. So I want to see, can you tell me why they're similar? Not just are they similar, but why? And the reason these was because we had two sides that were proportional, and we had an angle that was congruent. So they're similar by side angle side. Number 11. Are triangle KLN and NLM similar? And since this is all side, 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 that's what we're going to have to prove. So we need to figure out 2 is the smallest side of this triangle, and 4 is the smallest side of this triangle. So that would be KL and LN. And then we need to see if, so that's going to be 2 and 4. And we want to know, is it equal to the other sides? So we have to do them all. The next smallest side would be 3 and 6, which are KN and NM, which are 3 and 6. So far that looks good because both of those reduce to 1/2. And then we need the largest side. So the largest side of the little triangle is 4, and the largest side of the big triangle is 8. So 4 and 8 also reduces to 1/2. So LN corresponds to LM. All of these are equal to 1/2. So similar by side, side, side similarity. Okay. Number 12. Explain what additional information is needed to use angle-angle similarity to show that angle TUV is similar to triangle XZY. Well, if I add 37 and 65, I get 102 degrees, which means that this angle, if I do 180 minus 102, I get 78 degrees. So I know that one angle is similar or congruent, but I don't know if the other two angles are congruent. So I would either need to know that angle X was equal to 37 or that angle Y was equal to 65. So we need to know either angle X or angle Y. For lesson 7-4 and 7-5, we looked at similarity in right triangles and proportions in triangles. For a quick review, for right triangle ABC, triangle ABC is similar to triangle ACD, and is similar to triangle CBD, which we cut out triangles to show that. Also, CD is the geometric mean of AD and BD. AC is the geometric mean of AB and AD, and CB is the geometric mean of AB and DB, which I don't think I actually showed, but if you remember, the geometric mean was equal to the square root of A dot B. So when they say that CD, that was the first one we showed, where this would be A and B, and then here we'd have CD. But they're also saying that AC is the geometric mean of AB and AD. So if you took all of this, A to B and you took A to D, then CB, I'm sorry, AC would be those pieces. So you would do A and then you would do the whole thing B. You'd multiply them and you would get AC. Which we didn't show those, but you can use these notes on your test and just remember you can use all of this. So CD would be the geometric mean of AD and BD. That's the one I showed you. But also that AC is the geometric mean of AB and AD. And CB is the geometric mean of AB and DB. So you would just have to multiply those other numbers together and then take the square root to find the missing length. For triangle FGH, and this one was the bisector theorem, the triangle bisector theorem. For triangle FGH, FJ, which is right here, is to HJ as FG is to GH. And that just means that they are proportional. For example, triangle LMN, what is X? And so we can just set up a proportion here and cross multiply and divide. Right? So 9 times 4 and 6 times X. If you solve that, I don't love how they showed it, but here, this is 36. So 6x equals 36. So x equals 6. For exercises 13 through 15, use triangle RST to find each length. So we want to find RS. Well, they told us that we could use the geometric mean. So we'd use the whole length. Let's see, how would that look in our other triangle? If we kind of flipped it, we would be looking for this side. And so AC is the geometric mean of AB, which is the whole hypotenuse. So we're going to use this whole thing, 4 plus 12. So we're going to use 16 dot. And then they use, for AC, I should have used the purple highlighter because that's the one. If we're looking for AC, then we would use A to B, and we would use A to D, which is the little piece. And so the little piece of this is 4. We want to take the square root. 4 breaks into 2 and 2. 16 breaks into 4 and 4. So the 4 and the 2 both come out. So the answer to this would be 8. RS is 8. For ST, you want to know ST, and we'll use the geometric mean again, but ST is looking like, if we go back to our original triangle that they gave us in the example, ST would be in this one, CB. And CB is the geometric mean of AB, which is the whole thing here, and DB, which is the larger piece. So we're going to use the whole thing again, which is 16, and then the larger piece is 12. The square root of 16 is 4, so that comes out. And then 12 breaks into 4 and 3, and 4 breaks into 2 and 2. So a 2 comes out, a 3 stays in, and for 16, 4 and 4. So 4 comes out and 2 comes out. 2 times 4 is 8. And then square root of 3 stays inside. And so let me write that just a little bit nicer. We said the 4 and the 2 came out, so that's 8 square roots of 3. All right, and then they want us to find SU, and SU is the easier one because we worked on that one already. SU is the geometric mean of just 4 and 12, so 4 times 12. And 12 is 4 times 3. Since we have 2 4s, a 4 can come out, and square root of 3 stays in. For exercises 16 through 19, find the value of x. So this is what we just learned this week. We're going to set up a proportion. 32 over x is equal to 20 over 30. We're going to cross multiply and divide. Which will equal 48 when we do that. So multiply 32 times 30, divide by 2, and you should get 48. And that looks proportionally correct that x would equal 48. It looks proportional if we do that. 17 works the same way. We're going to set up a proportion. So 18 over x equals 20 over 16. I could reduce 20 over 16 just to make my math a little bit easier. But I'm going to grab my calculator and I'm going to cross multiply and divide. So after multiplying 18 times 16, divide by 20, I get x equals 14.4. So I cross multiplied those and divided by 20. Okay. For number 18, we want to set up a proportion where 8 corresponds to 5. This is the angle bisector theorem, the triangles, and x is proportional to 2.5. So 8 is to 5 as x is to 2.5. And I can see that 5, if I divided by 2, I would get 2.5. 8 divided by 2 is 4. So I can see that x equals 4. If you can't see that, that's okay. You can just put this into the calculator, multiply, and then divide. Okay. And number 19, we're going to have to use a little bit of algebra. So we're trying to figure out what x is. This whole piece is 5. So this piece, this smaller piece, is going to be 5 minus x. And now we can set up a proportion. 9 is to 6 as x is to 5 minus x. And we just have to cross multiply and divide. But like I said, we have to use some algebra. So when we multiply those, we'll have to distribute. And then we'll set it to equal to 6x. So 6x is equal to 9, parentheses 5 minus x. And then we will distribute, means multiply. 9 times 5 is 45, and 9 times negative x is minus 9x. So we have 6x equals 45 minus 9x. Now I need to add 9x to both sides. 6 plus 9 is 15x equal to 45. If I divide by 15, x equals 3. And that makes sense in the picture that x would equal 3 because then this little piece would equal 2. All right. Last question, number 20. Use structure. Given a right triangle, GHJ, with JK as the altitude to the hypotenuse GH, what is GJ the geometric mean of? Explain. This is making me think draw a picture. So I'm going to draw a right triangle, because that's what they told us. And then they said that the altitude is JK. So since the triangle has a J in it, I'm going to put a J here. The altitude is here. And GH is the hypotenuse. What is GJ the geometric mean to? So this piece out here, I'm going to go back to our demonstration too. That looks like either CB or AC. Okay. So in either case, if it's, let's just call it AC, that's going to be the purple one. So AC is the geometric mean of AB, which is this whole length, and AD. So I'm going to say that GJ is the geometric mean, okay, see that, of the whole hypotenuse, GH, and this piece here, GK. And that's all we need to do because they didn't give us any numbers or anything for us to plug in. So you can just say that. And that is our Topic 7 review, which you can watch tonight and study it. So you'll do well on the test. And you can use this on your test too if you took good notes.